Hi students, welcome to preliminary chemistry and the final video in the water series. This is looking at exothermic and endothermic dissolutions. I've left a couple of potential videos off on thermal pollution, and I've covered a little bit of the consequences of water's high specific heat on life in either other videos or as part of your assessment task. So that's why this is the final video, and we're going to move on to the final topic, which is energy, after this. And that's a kind of a good place to segue, because the last of these videos is looking at exothermic and endothermic processes, which are very closely linked to energy in any case. So let's pick up each of these one at a time, make sure we're really clear as we move on to the final topic. So an exothermic process is one in which energy is released to the environment. So what happens here is that we get a net output of energy as the reaction proceeds, and as a consequence of that, the surroundings become warmer. Okay? The temperature increases. Okay, and that's because some of the energy that was locked up within the bonds of the substance are being released. That energy is being released. It has to go somewhere. It goes out into the surroundings. So that may be into the water to heat up the water. The water may also heat up the container if it's in a colorimeter. Hopefully that energy is contained for us to measure it. But if it's in a beaker, it'll heat up the beaker. It may heat the air around the beaker, and so on. The delta H value for an exothermic process is negative. Delta H is a negative value. So you will see them written, say like this, minus 92 kilojoules, possibly even 92 kilojoules per mole. And this is how we express an exothermic process. And all you need to be looking for is the sign. If the sign is a negative, then that's telling you it's an exothermic process. Now, when we dissolve a solute in a solvent like water, we can have an increase in the temperature of the water as a result of that dissolution. And if we do, then we have what is called exothermic dissolution. It causes the temperature in a calorimeter or in a container to rise as energy is being released into the water as the dissolution proceeds. So as the solid processes into a cation with a positive charge and an anion with a negative charge, as this reaction proceeds, so the temperature of the water will increase. The energy quantity is a negative value in such cases as the total energy of the reaction has decreased the system as a whole. When hydrochloric acid is mixed with water, particularly something like sulfuric as well, very exothermic dissolution. And when they're mixed with water, they release energy. They release heat. And as a result, the temperature of the containers rise. And if we were measuring these in a calorimeter, we would see the temperature rise. We could measure that as a negative delta H value. The reverse of this, of course, is an endothermic process. In an endothermic process, is one which will absorb energy from the environment. So the heat is going into system, and as a result of that, the temperature will fall. The container feels cool. Feels cool. Cooler, shall we say. It may already be cold. But the temperature will drop. And as a consequence of that, the delta H value will be a positive value. Okay, so in this case, we would have a delta H value of positive 100 kilojoules. And again, maybe kilojoules per mole. So again, it's the positive value that you're looking for. That tells you that it's an endothermic process as opposed to the negative value of an exothermic process. And that plus means heat into the system from the surroundings. If the total heat of the system is higher, then that means that heat's got to come from somewhere, and that heat has come from the surroundings. So the water, say, will have lost that heat, so therefore its temperature will have dropped. Maybe a simple example can be ice melting. Now, ice melting is not a dissolution, so this is not a dissolution, because obviously water does not dissolve in water. We'll have a look at a couple of examples for you to have a look at it. Ammonium chloride is one of the ones I talked about in one of the previous slides. So ammonium chloride is a nice example. But if you think about ice melting, that'll hopefully help you understand this process, that when ice melts, the ice turns into liquid water, but the water that it's sitting in gets colder. And that's because energy has moved from the water, the liquid water, into solid ice in order to break those bonds. And as a consequence of that, this is an endothermic process. So think about that as a concept, and then look at the fact that there's certain types of solutes that we can dissolve in water that will cause the temperature to drop. That is, energy will be absorbed from the water in order for the dissolution to proceed. So again, if what we're looking at is ammonium chloride, then we're going to have ammonium ions and chloride ions, minus ions, and in this direction is the endothermic, and a delta H value that is positive. Because the energy is, the energy is positive because the total energy of the system has increased. The energy has come into the system from the surroundings, and hence the temperature of the surroundings has decreased. So we just need to make sure that we get a distinction between the system, the reaction system, and the surroundings. So if the energy is going in from the surroundings, then the surroundings will feel cooler and it'll be endothermic. And if it's going the other way, then that is the reaction system losing energy to the surroundings, then it will feel warmer and it will rise. So it will be exo. And that's the end of the videos for the water topic. Thanks for watching.